Hi, we're going to be looking at exponents today, and we're going to be looking at some of the properties. There's three that we're interested in: the product of powers property, the power of power property, and finally the power of a product property. Now, we're not going to get too excited about the names because they get a little bit confusing. We're going to look more at how they work and why they work. So the product of a power, the word product says we're multiplying. So if we have 4 squared times 4 cubed, 4 to the second power times 4 to the third power. I'm going to go ahead and leave some space here in between so we can be writing some things out. And I'm going to expand it down here. So if I've got 4 times 4, that would be my 4 squared term. And then I've got 4 cubed. This is 4 times 4 times 4. And remember, this is the base is 4, and this is the exponent. The exponent tells us how many times we see this base multiplied. An exponent is a repeated multiplication. So this exponent of 3 tells us the base of 4 was multiplied 3 times. Well, when I look at this, I see that I've got 1, 2, 3, 4, 5 total. So I could rewrite that as 4 to the 5th power. I'm going to rewrite that right here, 4 to the 5th power. Now, I think that there is something I can do. I'm going to be looking for a general rule. So that's my first example. Second one, let's look at 2 to the 4th times 2 to the 5th. And again, I'm going to expand it down here. 2, my base is 2. I'm going to multiply it 4 times. And my base is 2, and I'm going to multiply that 5 times. 2 are going to be multiplied together times 2. Now, if I look at this, and if I was to draw up my parentheses, I see that I've got 1, 2, 3, 4, 5, 6, 7, 8, a total of 9. So that would be 2 to the 9th. Now, I'm looking at this first one. I've got a 4 and a 3 and a 5, a 2 and a 4 and a 5. So if I was to look at a pattern and make a prediction, I'm predicting I add these. So it'd be 4 to the 2 plus 3. I would add my exponents. 2 to the 4 plus 5. I'm adding my exponents. Let's try this one more time. Negative 5 times negative 5 to the 6th power. This one looks a little bit different. This negative 5 right here in the front, I'm just going to leave it here. And then I'm going to have negative 5 6 more times. So that's the third. Okay, so this is negative 5 6 times. 1, 2, 3, 4, 5, 6. And here's this one. Now I'm going to tell you a little trick. When we have this with nothing to it, its exponent is really 1. But as I count these, I see 1, 2, 3, 4, 5, 6, 7. Negative 5 to the 7th power. Now if I come back here, this would be negative 5 to the 1 plus 6. It's going to get us our 7. And let's do one with exponents. X to the 3rd times x to the 7th. Okay, that would be x to the 3 plus 7, or x to the 10th. And we can expand that really quickly. X times x times x, x cubed, and then 7 of them. X times x times x times x times x. 1, 2, 3. So I see I've got 3 here. 1, 2, 3, 4, 5, 6, 7 here. 3 plus 7, indeed it does make 10. Okay, now let's move down here to the power of power property. Very similar, but a little tiny bit different. But I've got 5 to the 3rd raised to the 4th power. Well, I'm going to leave a space here, and I'm going to start expanding this. This would be 5 to the 3rd times 5 to the 3rd times 5 to the 3rd times 5 to the 3rd. The power of 4 says I've done it 4 times. Well, if I expand these a little bit more, well, let's back up. We're going to use the property up here. So this would be 5 to the 3 plus 3 plus 3 plus 3. Okay, we add our exponents here. Well, I'm going 3 plus 3, 6, 9, 12. So that would be 5 to the 12th. I'm thinking there's something I can do in here. I want to just double check. So I'm going to have 5 times itself 3 times, and 3 more times, and 3 more times. So I've got 5 to the third, 5 times 5 times 5, a total of 4 times, and I can count 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. Or I have got 4 groups of 3, and that's going to be kind of a big clue. Let's try a second example here. Let's go 3 squared to the 6th power. I'm not sure I'm going to love this, but hey, we're going to try it. So this would be 3 squared times 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 3 squared. Now, using our product of powers rule, we would add our exponents since our bases match. So this would be 3 to the 2 plus 2 plus 2 plus 2, 1, 2, 3, 4, 5, 6, plus 2 plus 2. Well, 2, 4, 6, 8, 10, 12. This would be 3 to the 12th. If I expand this, this is 3 times 3 times 3 times 3 times 3 times 3. And I'm expanding these because this way you've got a tool so that if you don't remember the rule, you can still figure out the answer. Because I can't remember the rules, but I can figure out the answers with a couple of simple examples. So 1, 2, 3, 4, 5, 6 groups of 2. Well, 6 groups of 2 is 12. 2, 4, 6, 8, 10, 12. So we do have 10 to the 12th. Now, I'm looking up here and I see 3 and 4 to make 12. 2 and 6 to make 12, and that is just a coincidence that I picked 12 for both of those, sorry. 3 times 4 makes 12, and 2 times 6. So I am thinking my rule is 5 times 3 times 4, and 3, I'm sorry, not 5 times 3 times 4, 5 raised to the 3 times 4 power, and 3 raised to the 2 times 6 power. Do you see why I'm more interested in you being able to figure out a pattern than to memorize a rule? Because here we are adding. When the bases are the same and we're multiplying, we add. When we take an exponent and raise it to a new power, we multiply. Super easy to get confused here. So let's try one now with an exponent. Let's go w to the 5th raised to the 4th power. So using our rule, that would be w raised to the 5 times 4, which would be w to the 20th. Let's expand that. W, I'm going to put these in groups, times w times, well, w, 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 that's to the 5th, w, 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 and let's squeeze it in here, W, 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 W. So I've got 1 group of 5, 2 groups of 5, 3, 4 groups of 5. Well, 4 groups of 5 is 20. Or the other way we did this, W to the 5th plus 5th. Let's try again, let's back up. Plus 5th, because that would be W to the 5th times w to the 5th times w to the 5th times w to the 5th. Again, pulling it back up to this top one. Well, that's where we get the adding, and this does indeed add to 20. Cool. Okay, let's take a look at our very last power. It's the power of a product. It's actually probably the easiest once we look at it a little bit carefully. So if I've got 6 times 2, that quantity to the 3rd power. That would be 6 times 2 times 6 times 2 times 6 times 2, and I'm going to regroup. That would be 6 times 6 times 6 times 2 times 2 times 2. Forgot to leave space for my answer. So 6 times 2 to the third equals 6 to the third times 2 to the third. Okay, let's take a look now. If we go 2x raised to the second power, we're going to square that. We're going to actually leave 2 spaces for answers here. So this would be 2 times x times 2 times x. Regrouping, that would be 2 squared times x squared. And I regrouped, it was 2 times 2 times x, in case you missed my quick grouping here. So this is 2 squared times x squared. Let's see if I can get this a little bit better centered. Okay, so this is 2 squared times x squared. Well, 2 squared is 4. X squared, I went ahead and expanded that answer. Let's do one more, negative 3x to the third power. Okay, so that's going to be negative 3 times x times negative 3 times x times negative 3 times x. We're going to regroup it, negative 3 times negative 3 times negative 3 times x times x times x. So this would be negative 3 cubed times x. Negative 3 times negative 3 is 9. 9 times negative 3, this would expand all the way out to be negative 27 times x. Thank you very much.